Hello, welcome to this very first video of the Geogramblings blog, of the Life Geographic blog. So the first topic I'm going to cover is about climate attribution, and I'm going to use the case study of the Australian bushfires that have been taking place recently, still ongoing at the moment, although things have died down quite a bit at this point at the end of January. So the first thing to do is to start off with the definition of what do we actually mean by attribution. Now, to take the dictionary definition, it's the action regarding something as being caused by a person or a thing. But in this instance, of course, we are more interested in what we mean from a climate perspective. So, in my opinion, there's kind of two things that we can actually look into. One is the attribution of what's to blame for climate change. How much of it is due to human activity, how much is it due to natural causes. So there's that kind of attribution. And the second kind, which is something we're going to talk about quite a lot in this video, is regarding the impacts of climate change. So to what extent is extreme weather events like the Australian bushfires, like flooding events, are they due to climate change? So those are the two we're going to focus on today. So let's focus on the bigger picture. So here's a really interesting graph if we have a look at this now. So we have the dots here are the observed temperatures that we have seen so far, so dating from 1850 all the way here to the 21st century. And these lines are all to do with what can be attributed to these temperature changes. So we have three lines here, and we have this blue line, which is to do with natural factors. So these are studies that have taken place with regards to whether they're due to volcanic activity or sunspot activity, for example. In fact, you can see the eruption of Krakatoa here in 1883 and the eruption of Mount Pinatubo here, and you can see how they have actually had a cooling influence on the Earth's atmosphere. But if you take the red line here, which goes up to there, these are all the human factors put together. So that's not just greenhouse gas emissions, that's land use change also. But when you combine these two factors, you have the grey line right here, and you can see that that matches quite a fair bit with these black dots. So that's one kind of attribution. And what I strongly recommend that you do is you have a look at this Carbon Brief article, which is really good. And it talks about all the studies that go into this graph. So what we'll do now is that we'll have a look at some of the language that's been used in some of these what we call attribution studies, or when people have commented on whether specific events have been able to be attributed to climate change. So first of all, if we go to 2003, this was the very infamous now European heatwave that took place in August of 2003. And Nigel Reid of the Met Office used the word impossible to say that at this stage it's impossible to say that the events of 2003 could be attributed to climate change, at least statistically. If we move forward to now 2005 and we refer to like Hurricanes Katrina and Rita, you could see here that Kerry Emanuel from MIT is very cautious to attribute those hurricane events to climate change. So I'm not sure that it would pass statistical muster with regards to relating these events to climate change. Fast forward to 2012, and now you have a study in 2013 from Zhu et al. At the Chinese Academy of Sciences, talking about the flooding that was taking place in China in 2012. And now they're kind of starting to talk about whether climate models have the ability to attribute to individual events to climate change. And they're not quite sure. We are unable to confirm or reject. But now we're starting to move into the possibility that we could attribute certain events. So studies have moved along a fair bit there. Again, a little bit more recent, the 2016 drought in West Africa. Now we are getting actual language in scientific attribution studies that are attributing specific events to some degree to climate change. So in the space of these 14 years, you can see how things have come along quite there. But what about, of course, today? What about 2019 and the Australian bushfires? Well, we'll come back to those in a minute. So here we have the number of studies that have taken place with regards to attributing specific events to climate change. To what extent is an individual event attributed to climate change? Well, now let me just clarify something here. This is not a graph of showing how many events can be or cannot be attributed to climate change, because we don't want you to misinterpret this and think, oh, more and more events are able to be attributed to climate change. This is quite simply the number of studies that are taking place with regards to attribution to climate change. Now you'll notice that 2017 here is quite low, and that's because there was a conference at that all of these studies were taking place, and so not very many were published at the time. But you can quite clearly see that we have an increase in the number of studies taking place. And you've got lots and lots of articles, including this one from Scientific American, which are stating that attribution science has become so stronger, the climate models become a lot more reliable, and how we can attribute have become a lot more reliable, that we even now have statements to say that scientists can attribute at least some measure of an extreme event to climate change. So let's now move on to the topic at hand, the Australian bushfires that have been taking place in this Southern Hemisphere summer, so 2019-2020. So let's give a little bit of background about why these Australian bushfires are taking place. You may have been hearing this quite a lot recently. It's something to do with called the Indian Dipole, the Indian Ocean Dipole. And you may be more familiar with another oscillation. An oscillation is where something changes from one phase to the next and backwards and forwards, called El Nino. So that one may be more familiar to you. This is another phenomenon where you get a kind of seesawing between warmer temperatures and cooler temperatures in the Indian Ocean. This one's not as well known as, at least until now, with the Australian bushfires. So this particular event has been due to a really, really strong positive signal. That's the difference between the warmer temperatures in the west here to the cooler temperatures, plus 2 degrees of a difference between these two areas. That is exceptional. Last time that actually happened apparently was around about 6 decades ago, about 60 years ago. Normally, it's no more than plus or minus 0.1, 0.2 degrees Celsius, the difference between here. So this is an exceptionally strong positive Indian Ocean dipole that we have here. Now, of course, where you've got warmer temperatures, you're going to have more rising air, you're going to have more moisture falling from the atmosphere as rain, so you're likely to get floods and storms here, whereas here you're more likely to have sinking air and dry conditions and drought. But can we attribute this to climate change? That's the main question. Now, I strongly recommend a specific website. It's relatively new, and it actually mimics the fact that climate science, attribution science, has come along a long way. And that is this website, climatesignals.com. So I strongly suggest you take that out. So this diagram that you see is from Climate Signals. And what it does, it takes individual events and changes in the Earth's atmosphere and tries to link them to greenhouse gas emissions and to global warming. And it does it very, very scientifically. So what you can do is that the links that it makes, it'll actually give you links to scientific studies, and so you can check them out yourself and see how strong and reliable they are. So let's have a look at the Australian bushfires in particular. So of course we have greenhouse gas emissions, and to what extent are they increasing the risk of fires here? Well, you've got your myriad of kind of connections that take place here, because we know that actually the changes aren't linear, they're not straightforward, they're actually quite complex. So let us take this middle kind of lane, for example, to see what the links are quite here. So it's very, very well established, the science is completely conclusive that we know that increasing greenhouse gases is leading to global warming. But then this then leads to an increase in your temperature of your air masses, and therefore your extreme heat waves become more frequent and more intense. And because of higher temperatures, evaporation, this is, of course, increasing the risk of drought, leading to wildfires, etc. But of course, we have these two other lanes here as well. And at the top here in particular, we've got these two things here. So your land starts to heat up as well, and that dries out due to excess evaporation. And that then leads to your drought, so that's all feeding into each other. And then we have what we've just been talking about the Indian dipole, so the seesawing oscillations and things like that. So, you know, your global circulations are changing, the way that heat moves from one place to another is changing. And this is causing to your extreme heat to occur. So this is all feeding into each other. Now this kind of dashed line here is indicating that the link isn't so strong and the climate science attribution is Not 100% sure what the link is, but the risks suggest, and all the models suggest, that there is definitely a link between this and this here. I'm not going to dwell on the effects too much because it's been well documented and you can find lots of information about the effects. But what I would like to share to you is two images in particular that I find really, really interesting. And you can find these images by going to ABC News and searching for wildfires rage through parts of Australia. And then you get to flick through about the 40 or so pictures that they have. We all know that the wildlife has been particularly impacted by this bushfire. But what I really want to point out in this picture is the amount of effort, the care, the emotion that the volunteers have. I mean, there are thousands of volunteers that are giving up their time, putting their lives at risk. And you can see on this volunteer's face here that it's very, very emotional work as well. And I think a lot of that gets forgotten sometimes when events like this happen, that the emotional toil are not just the victims, but the volunteers and the people who try and do amazing work to save people's property or safeguard people's property or save people's lives or rescue animals. Sometimes they're not forgotten, but they're usually put aside on top of the more dramatic effects. And this picture is very interesting from my point of view, and I just want you to take a look very closely at this one. You know, you could say it's a standard picture showing, unfortunately, someone's house being lost to the fire, but take another look at it. Look at the income level that these people may be on, because they have a swimming pool, they have solar panels. And to me, this strikes that the impacts of extreme weather events, which could be attributed to climate change, are not just going to affect the poor, they're going to affect people on all income levels. So these people may be well off enough to own a house like this with a swimming pool, but now you think about the amount of damage, the amount of costs involved that they're going to need to recuperate their insurance is going to be very, very hefty on this. So it's really interesting to see what the impacts are like on various income levels, not just the poorest, but also maybe climate change is now showing impacts which can affect people up to the top income levels also. So I'll mention towards the end of this video that there's been a fantastic video from WeatherQuest, and I'll mention WeatherQuest at the end of this video as well, where Dan Harley talks about the impact of or the generation of Pyrocumulus Clouds. So I won't go into too much detail here, but I do want to show this absolutely amazing video. This is not from this bushfire, this is from a few years ago, and it's recorded so they can study how these Pyrocumulus Clouds are formed and what kind of impacts they have. But you have over here, so your smoke plumes are rising, and of course they're condensing and cooling and forming clouds here. And they are generating their own storm system here, and you can see the amount, I mean, you can definitely see a well-defined cumulonimbus cloud here, and the lightning is striking. You see that very, very clearly, and you'll see here a bolt of lightning that's hitting the ground. And you've got already, just right there, so if you see already here, you've got dry, tinderous, very, very, very susceptible. You know, any lightning that taking place could set even further fires off. So those Pyrocumulus clouds will fuel more fires themselves. So if we move on to responses now, there is a fantastic, first of all, let me mention there's a fantastic podcast that I think every single geography teacher should sign up to, and that's the BBC's World Service's Digital Planet podcast. Every single thing that they cover, in my opinion, can be related to some form of aspect of geography, and you can slot anything that they talk about into something that you teach. In particular, for this example, definitely check out their episode about tracking Australian fires. And there's a little snippet there, and this is the best thing about the Digital Planet podcast, is that they do little 1 or 2 or 3 minute snippets, which are so easy to integrate into our lessons. So let's have a listen to this little snippet here, which is about an app that is keeping Australians safe from bushfires, and it describes the app, and of course, you should go and look at the app online yourself.
My name is Corinne Podger, and I live in a town called Mittagong, which is about an hour and a half southwest of Sydney. Just to the north of us is a huge national park which extends all the way up to the Blue Mountains. Just to the north of us is a fire that's been burning for several weeks, and that fire's name is Greenwattle Creek. The way that we keep track of these fires is by both an app on our phones and on a website which is called Fires Near Me. These are both run by the New South Wales Rural Fire Service, and what I've been doing every single day and several times a day when it's been very hot weather is to check that app or to check the website. So when I go onto the app, it will tell me, based on where my phone's location is, which is the nearest fire to me, and also what is the status of that fire. So the fire status might be just advice. In other words, it's burning, you're not currently at risk, you don't need to worry about it too much, but you should be advised that there's a fire nearby. Then there will be watch and act. And this means that you really need to know what your fire plan is. So if you're going to make a decision to stay and defend your house, you need to know that. If you're going to evacuate, you need to know that. And then there is emergency warning. And that means you may be in an area which will be hit by fire either immediately or very soon. And that's the moment to put your fire plan into action. So if you've decided to leave, then that's the time to evacuate. And if you've decided to stay and defend, that's the time to be ready to be out there with your hose. Make sure that you're there fighting off that fire.
So that's really, really fascinating. And again, I strongly recommend that you give that a listen and the whole podcast episode a listen too, because there's some really interesting things also about how amateur radio people are kind of reporting the impacts of the fire and how that's helping the communities to respond to the fire. So to finish off, I want to, geography teachers are fantastic with this. Whenever there's a current event or whenever there is something ongoing, they always rise to the challenge and produce lots and lots of fantastic resources. One in particular I like is from Jennifer Monk. She's very well known in the geography circles here in the United Kingdom. Just go to her tweet here, check out her tweet and have a look at her resources. Other resources are available, but this is a particular one that you can definitely get your teeth into. Okay, thank you very, very much for watching. Hope you enjoyed this first video. There'll be more to come in the future. I want to give a big thank you to WeatherQuest. WeatherQuest has supported this video. They've allowed the length of equipment and the technical expertise. Strongly recommend you check out their YouTube channel as well. Until next time, thank you very much.